This video introduces the substitution method. Alright, so notice that neither equation is solved for x or y. So we're going to choose one of the equations and then solve for x or y. So we'll solve the first equation for x so that we'll not introduce those tedious little fractions when we're solving. Alright, so to solve the first equation for x, we're going to subtract 2y from both sides. Alright, since x equals 7 minus 2y, we now substitute 7 minus 2y for x in the second equation and then solve for y. So let's go ahead and do that. Alright, now don't forget to insert the parenthesis when you're substituting 7 minus 2y for x, okay? So we're going to distribute the 2. Okay. Now we're going to subtract 14 from both sides, because remember it's added over here, okay? So we need to subtract it from both sides because we're trying to isolate the y. So we're left with 2y on the left and minus 1 on the right, because minus 14 plus 13 is minus 1. So now, again, we're still trying to isolate the y, and right now minus 2 is being multiplied, okay, to it. So we're going to undo that multiplication by dividing by that whole coefficient, okay? The coefficient is minus 2. So these cancel out, and you're left with y equals 1/2. So to find x, let y equal 1/2 in the equation x equals 7 minus 2y. Okay? So let's go ahead and do that over here on the right. Alright, so we can see that x is 6, so we're going to check the solution in both equations of the original system, okay? And so that does check out. So the solution is 6 and 1/2 for the y coordinate. Alright, so let's summarize how to solve a system of equations by the substitution method, okay? So the first step is to solve one of the equations for one of its variables. The second step would be to substitute the expression for the variable that you found in the first step, okay? Do that, put that into the other equation. The third step is to solve the equation from the second step to find the value of one variable. And then substitute the value that you found in the third step into any equation containing both variables to find the value of the other variable. Alright? The final step is just basically check the proposed solution in the original system. Let's solve another system of equations using the substitution method. Alright. So if you look at the system of equation on the screen here, you'll see that the second equation, it's already solved for x in terms of y. So let's just substitute 6 plus 2y for x in the first equation and solve for y. All right, so now we're going to apply the distributive property here. We're going to distribute that 1/2. So we're going to simplify. So y minus y is 0y. So we're left with 3 equals 3. Okay, so we've arrived at a true statement, right? Because 3 does equal 3, all right? So this indicates that the two linear equations in this original system are equivalent. This means that their graphs are identical, okay? So let's look at that. Let's go ahead and graph those two linear equations. So if we graph 1/2 x minus y equals 3, we get this line. Okay, and then if we graph x equals 6 plus 2y, well, we get the same line. So as you can see, right, the graphs are identical. Okay, so there is an infinite number of solutions to the system, and any solution of one equation is also a solution of the other. All right, let's do one more. So let's solve the system 6x plus 12y equals 5 and minus 4x minus 8y is 0. All right, so let's choose the second equation and then solve for y. Okay, so let's go ahead and do that. Remember, we're trying to isolate y, so we're going to divide by the coefficient, and the coefficient in this case is minus 8. All right, so y equals minus 1/2 x. All right, so now let's replace y with minus 1/2 x in the first equation. We'll do that up here. Okay, well, as we can see, the statement is false, right? Because 0 does not equal 5, all right? Well, this indicates that this system has no solutions, all right? So what does this look like on a graph, all right? Let's go ahead and look at that real quick. Okay, so here's the graph of the linear equations in the system, right? It's a pair of parallel lines. So that right there tells us that there are no solution, okay? There's no solution for this system of equations. Okay, and that concludes this video of solving systems of linear equations by the substitution method.